going to go ahead and hit the start record button, and I'm going to minimize OBS here. And I am going to welcome everyone to the very first episode of Handmade Hero. I am super excited about this project. I was thinking that this was going to be basically me on a live programming stream making a game for people to sort of learn from, but basically that there were going to be like 5 people watching because I assumed that it would take a long time to generate any interest. But actually the response from people has been completely overwhelming. I was so psyched about it, and it's been so great to see so many people here, even on the test stream that we did where we were just kind of practicing stuff. Everyone was awesome, the community was awesome, the questions were awesome, and it was just fantastic. I had an absolute blast doing it, and so I'm really looking forward to this. Before we get started, I just wanted to say a couple things, and I'll probably try to take a minute at the beginning of every stream just to repeat these for anyone who's coming back, who hasn't necessarily seen the live stream before. Basically, this is a series where we program an entire game from scratch with explanations of everything I'm doing. Now, in order to actually finish an entire game at some reasonable point in the future, I cannot explain everything in complete detail, so I have to constantly reference back to things that I've already explained. And I have to trust that you're going to be able to keep track of the things that I explained, and if you don't understand them, ask questions. You can use the email link on handmadehero.com. You can basically go there anytime you want, and there is, handmadehero.org. You can go there anytime you want, and there is an email a question button, so you can ask there. You can ask on the Twitch chat at the end of the stream. There'll be a time for questions and answers. Or you can just ask on internet forums, stuff like that. There's been a whole community of people who've been helping out. So I won't be able to drill down into everything every time. I'll have to reference back to stuff that we've already done. So please keep that in mind. It's okay if you get a little lost, if we blow past something that we covered earlier on a different stream and you're like, what was that? It's okay. All of the videos will be archived. You can go back and watch them again. You can go sort of look and see if people in the comments have added stuff, and we'll try to have a lot of resources available for you. You can also, if you pre-order the game at any time, you'll get all the source code to it. Every night you can download the source code, follow along, play around with it at home, and all that stuff. So hopefully there'll be plenty of resources for you. With that said, I am going to get started, and please keep in mind as we do this, that basically everything that I'm going to show you here is one way to code a game from scratch. It is not the only way, and I don't want you to think that you have to do absolutely everything I do the way I do it. I'm just showing you the way that I make games so that you can see one complete way of doing it and see that where there's nothing left out. But you should develop your own techniques, and you should feel free to experiment with your own styles and try different things and see what works the best for you. All right, let's get going. So the first thing I want to do is I got to actually build something. I have to get a project started. And as anyone who's ever actually done a game, or really probably any computer project knows, getting a project started is a bit of drudge work. It's really unfortunate, but it is. And basically what happens is you're going to have to create something that allows you to build the actual text files that you type in that are the source. You're going to have to do something that allows those to get built into executable. And in the intro stream, we talked about the basics of that. So if you're unfamiliar with it, you're going to have to go watch that to sort of get you up to speed. But hopefully most people understand what a compiler is, what a linker is, what an executable is. A compiler is something that takes the source code that we type and it turns it into partially executable code. And a linker is something that gathers all that executable code and puts it into an executable, which is something that we can actually run on our computer. And what we did in the test stream, where I was sort of teaching people very, very, very basic things, what we did in the test stream is we used Visual Studio, which you can download for free, actually. This is Visual Studio 2013 Community Edition, and that's what we'll be using for compiling and running our code. You can actually go get it at visualstudio.com because Microsoft has now made it free for small teams or personal use, which you are if you're one person at home following along. You can download it here and install this exact same thing. It doesn't cost any money. You can use it for free. So this tool right here is what we're going to be using to debug and compile. And what we did in the test stream is we actually used this to make our project. But I never do that in real game development, and most real game developers don't either, although some certainly do. So if you want to, you can certainly try to do that. The way that I do things is I actually don't edit in here, and I don't build from in here. I only run and debug from in here. I basically use this tool as my debugger, and I access its compilation functions from the command line. Now, we didn't cover the command line in the intro stream, so I'm going to talk a little bit about that here. Basically, what happens is on your machine, if you are on Windows, if you're on Linux, you already know what a command line is because you don't use Linux without a command line. But if you're on Windows, even if you're a programmer, it's possible you may never have even used a command line. It's possible these days that could be the case. So if you go into your All Programs and you look in under Accessories, there is a thing here called Command Prompt. And when you click on it, you get this little text window. And all this text window is it's something that allows you to basically have a dialogue with your computer the old-fashioned way. You can type a command in, you can hit return, and it spits something back out to you. Now this is super tiny because the fonts aren't set. I have my own over here that I set the fonts to, but I just wanted to show you the one that comes up when you launch it by default. And basically we're going to be using this to sort of show you how to execute some commands, and I'll show you why you want to execute commands through it in a second as well. But if you're like me, you want to customize that a little bit. If you right-click on a command prompt shortcut, and I assume you all know how to do shortcuts, but just in case, you can Control-click and drag this out to the desktop. You can make a shortcut for it or anything like that. If you right-click on a shortcut to a command prompt and hit Properties, you can go in here and you can customize a bunch of stuff, like the font, where it is on the screen. I won't belabor this because it's pretty self-explanatory, but you can basically customize it, and I did that. I think during the sort of the lead up to the show, people were saying that the fonts were a little too dark, so I'm going to go ahead and actually just make them a little brighter in this one. And we made them brighter in Visual Studio and in Emacs, and people seem to think that was good. So I'm just going to brighten those up a little bit there and hit OK. Once you've got that customized, when you double click on it, you'll get precisely the stuff that you set, and in the window will be where you want it, and you can use that. And like I said, I made the fonts a little bigger so they're easier to read on the stream. So first things first. What I like to do, and this is unusual, I don't know many people who do this. I have heard people tell me that it is if you used to use an Amiga, the computer from the late 80s, if you used to use an Amiga computer, then you do this. I don't know if that's true, but that's what I've heard. I did use an Amiga for a long time. That was one of my favorite computers, probably my favorite computer of all time. What I like to do is I like to use a command called subst. And I'll actually go ahead and delete the subst that I actually already set up on this machine just so you can see how it actually works, or at least I'll try to. Let's see if I can get that to work. Yeah. So basically what I like to do is on Windows, you've got these drives, right? I've got drives in this machine that are actually drives. I've got the C drive, I've got the D drives, that's whatever. And you can quickly always refer to those in the File Explorer or whatever by just hitting, C:, or whatever, D:. What I like to do is I like to take the place on my drive that I'm going to be doing my development, and I like to subst a fake drive letter so that it points there. So this command subst, you can type it in on the command line subst. It doesn't do anything if you just type it by itself. But if you type subst with a /?, right, that's the universal symbol for, well, you know what? Let me go back to the big font version. If you type subst /?, you'll get help on it. Basically, all it is it's a command that allows you to type subst and then a drive letter that you want to make, basically a fake drive, and I'm going to use W:, and then give a path on the actual hard drive where you want that drive to essentially exist. So I made a directory on the J drive, that's an actual drive on this machine, and I made it called work. That's what I made. And so I'm going to subst W:, to be work. And now, instead of having to always go to J:, and CD to work, now that's basically CD is probably a new command for people who don't know the command line. Basically, this is how you move around directories. So if you remember up here, when you're working in like a file explorer, if you look at this thing, this is a path to a file, right? If you want to move around on an actual command line, you can use the CD command to do that. So, if you start out somewhere, like I started out on W, I want to go into the Handmade directory. Now I'm in the Handmade directory, and it always prints out what it is here. Again, that's not really, you should be able to learn this separate from this stream. That's stuff you can look up, just how to basically use a command line. So I'm not going to teach you a ton of stuff. CD ... goes back and so on. You should just go learn those if you're totally unfamiliar with command lines. Anyway, I like to sub a drive to it just because it really makes it more convenient. It's less typing for me. And it's so that if I ever need to hard code debug paths into something, it makes them so they're not quite so hard-coded. I can refer to w : something, and then if in the future I move the driver, I move where it actually is on the physical hard drive around, it's no big deal because I can just subs the drive to the new location, right? So it's totally good. No big deal. All right. So anyway, I made a directory here. It's the Handmade directory. And what I did, and I'll actually show this in Explorer too, for those of you just who are sort of warming up to the idea of having a command line, you can see that I've actually, if you actually go into the Explorer, in the JWork Handmade directory, you can see that the directory listing in here is the same as the directory listing in here. And dir is what gets me that, right? No big deal. Again, I'm really not going to spend a lot of time teaching this stuff because hopefully this is stuff you can just go read a basic tutorial webpage on. And so I don't want to spend a lot of time on the stream learning that. But I'll just mention the things I do as I go so you know. And basically, I made a MISC directory here. And the reason I made a MISC directory here was because I decided to put my .emacs config file in there. Because I'm going to be using Emacs to edit on this stream. And I figured that anyone who for some reason wants to edit in Emacs along with me instead of editing it in some text editor that they find fun and nice, they will be able to do that. So anytime you actually go and if you download the Handmade Hero source code, it'll have that .emacs file in there in case you want to just use the same setup that I'm using. But other than that, you will notice that the directory for Handmade is empty. That is because we are going to be doing absolutely everything from scratch, so there's nothing in there. And absolutely everything that it takes to run this game will be written in this directory, so it will be full of good code by the end of the series. Now, the first thing we're going to do is we are going to launch Emacs, and we are going to make a simple single CPP file, single source file, that we can use to actually get our build going. And like I said, this is going to be the drudge work. In fact, tonight will probably be the most drudge worky night. It's too bad to start off the series with the drudge work, but hey, this is where projects actually start. There's nothing you can do about it. So I am going to go ahead in here, and inside Emacs, there's all kinds of stuff I can do. I'm not going to explain all of these things because, again, I don't even necessarily encourage people to use Emacs. It's just the editor I'm fastest with. So I think you should all use the text editor that you're fastest with. But hey, if you really want to follow me, you can follow me and use that .emacs file. So I'm going to make a directory in here. I'm going to make a directory called code. And inside that directory called code, I am going to make a handmade, actually I'm going to call it win32_handmade.cpp, right? Now I have Emacs programmed to insert a little header into each of these. And what this header actually is this is sort of a little bit anachronistic these days, but I'll tell you what it is. Basically, inside a comment, what it basically does is it says, hey, I am going to actually put little markers in that some external tool could come along later and fill in the file name, the date of the file, and the revision if it was checked into source code control. So all of those are actually totally unnecessary. It's just a comment. It has nothing to do with the code, obviously. But it basically just puts in some boilerplate automatically for me anytime I create a source file. And this allows it to play nicely with people's revision control systems that do this kind of stuff. So if you happen to check the source code in to a revision control system that you prefer, and it has keyword replacement, you can turn that on, and all the files will get marked cleanly so that you can see them. Now, I am going to take one quick second, because I think we didn't do this at the beginning of the stream. I am going to see if I can brighten the comments a little bit, because I know that people were saying they were having trouble reading some of them, and I think it would only take a second here to do that. So list colors display, let's take a look. Those of you who were with me at the beginning of the stream, I greatly appreciate your help figuring out exactly what the color should be for everything. So I feel like one of those grays looks good. Maybe a gray 50, let's say. Gray 50 sounds good to me. We'll try that, and we'll see. Gray 50. And we will see if that makes it a little bit easier to see. Okay. There we go. So what I'm going to do in this file is absolutely nothing. I am just going to insert the entry point for Windows. Now, those of you who actually were in the intro stream, we covered this a little bit, but basically what you want to do whenever you're programming on Windows is you're going to need to use something called MSDN. So it is basically the documentation for everything that is on Windows. So if I search for WinMain, which is the entry point for Windows, you will see that the first hit is msdn.microsoft.com, and that is the documentation for Windows. Now you may ask me, how do you know how to search for WinMain? How do you know what to type in there when you search? Well, the answer is WinMain you probably could have figured out because you could go look on some tutorials for Windows or that sort of stuff. So that's not that interesting of a question to answer, but what is interesting is for the rest of programming in Windows and all the minutiae, how do you know what to search for? Yeah, there's MSDN and maybe there's a table of contents, but trust me, it's huge and it's very hard to find your way around. The answer is that's one of the reasons I'm doing this series. I don't think there is any way you could know what to search for. The whole point of this series is basically to give you all those things that you should search for, to show you how to make stuff, and I'll go through it quickly. So like I said, I can't sit here and explain every last little thing, but this whole series is supposed to be that backbone where you can go, how did I know I was supposed to search for this crazy thing in Windows? It's like, you weren't. It's just a lot of bad trial and error and years of experience in the industry that exposes you to these things so that you know to search for such and such. And so this series is supposed to actually be that backbone that tells you what to search in. But just because I'm going to show you all those things, it doesn't mean you shouldn't learn how to use MSDN. You really need to learn how to use this website to read these pages and to understand what they say, because it's how you're going to be able to fill in all that knowledge. Because like I said, I can't go into every last little detail on what every last thing is. I can only give you, a good explanation of each part, and then you're going to have to go kind of, do more exploring on your own to fully understand absolutely everything that I do. If I don't have, if I haven't sort of been able to kind of go into like, here's why there's an H instance and here's what the kernel did in 1994 and all that stuff, you kind of, the stream would go on forever. So this is the entry point that Windows will be looking for. And technically it's actually the entry point that the C runtime library that links with our program will be entering, but we'll see that in just one second. For now, we have to concentrate on getting our build going. So what I'm going to do is I'm going to cut this out here, and I paste that into our program. Now what we want to do, and these ins are little markups. I don't know why they leave them in here. They're kind of annoying, actually. These ins are little markups that you don't actually want to have in code. They're not actually C code, really. They are basically just something that lets you know that the parameters are being passed in to you, as opposed, or into whatever the function is that's being defined, as opposed to out parameters, which come back out to you. So I am going to include windows.h for now, which is the header file on Windows that has all of the definitions, well, it's not actually all, many of the definitions that are functions that we will need to call in order to get our job done, to actually get us up and running on Windows. And again, if you don't know what some of these things are, I highly recommend you go watch the intro stream that we did, the test stream. I'm kind of assuming that people can sort of read C code, and if they can't read C code, definitely go back and watch that intro stream, because it will teach you how to read these things so that you won't be confused by that. So, and it's all, I should also say, if you go to handmadehero.org, it's on this archive button. This archive button right here has all the stuff, intro to C on Windows, that sort of stuff. So if you're totally new to programming and totally new to C, you definitely want to start there. But assuming that you know what this stuff is and could read C reasonably okay, or at least a little bit, basically what we're doing in here is we're including a header file, and that's just a bunch of definitions of functions we can call and types we can use that Windows wants us to use to communicate with us. And this is going to be an entry point where Windows will pass us a handle to our executable. This hprev instance is not something we actually need to use. It's sort of legacy at this point. Our command line, the command line that got set when we ran the program, and end command show, which I'll say what it is again because it's so darn funny. I said what it is on the intro stream, but I'm going to say it again. When you actually look at an executable, so for example, if I go out here to one of these guys and I hit properties, you see this little run dialog box. It's like run : and it's got this drop down, normal window, minimized, maximized. Well, whatever that gets set to, when Windows calls into us and starts up our code, it's going to be here. It's that int command show. Like, it was so important they decided to pass it to you. So yeah, there you go. Anyway. So I'm not going to do anything here other than return 0 for now. So I'm just going to leave this as a stub. We're not going to do any code, because what we need to do is we need to get this building and executing as it is. Now here's how I like to do builds. And this is going to shock and horrify absolutely everyone out there, and I apologize for that. But you know what? It's how I build stuff. It's how I build all my stuff these days. And I'm showing you how I program games. So that's where it's at. Here's how I do it. In the directory, the root directory of the code for the project, basically wherever I'm going to be doing stuff, I make what is called a build.bat file. And what a bat file is, and the reason that I was talking to you guys about the command line, which is this thing where you can type in commands that do stuff and I can get printouts back, a bat file is basically just a script. It's a script of things that the command line should do. That's it. And so what I typically do nowadays is I don't actually bother using a make system or anything. What other programmers do is they typically have something called a make system. So basically, like for example, GNU Make would be an example of an original one. They use things called Ninja, for example, build system. I don't know how to actually search for that because there are real ninjas in the world. Here you go, a small build system with focus on speed. They use that. They use something called CMake. A lot of these things, people love their build tools. They love their build tools. They just like to have build tools on top of build tools, and build tools that launch scripts that run other build tools, and build tools for analyzing your build tools, and build tools for optimizing the build tools that optimize your build tools. They love it. I don't love it because usually what I find is I spend all my time screwing with the build tools, just trying to get stuff to build. So I just said, screw it. There's no more build tools. There's a batch file. There's just a batch file. That's all there is. And the batch file compiles the code. It compiles all the code every time. Now the reason that's going to shock and horrify a lot of people is because they're going to be like, oh my god, you compile all the code all the time? The whole point of a make file is that you only compile the code that changed. And that's what a lot of those build utilities do. They try to optimize things so that they only do the minimum amount of work necessary to rebuild a project. And when projects get very large, they can get very slow. But I have found that actually, if you just code sanely, I now compile very large programs, certainly larger, considerably larger, than what we will take to make a good, full professional quality game on this stream. Much larger, by just using a batch file, and it's only a couple of seconds. So I think the time has come for people to maybe start rethinking the way builds work, but, you know, again, like I said, just me. So what we're going to do here is we're going to start with a line that's at echo off. That is nothing other than basically echo off is a command that says don't print the things in this batch file as you do them. Don't show me every line that you're about to run when you run it. And this little at symbol here is basically a thing that says don't echo this particular line. Because basically what will happen is, you know, let's say I saved that here. So I've got that build.bat. So I go into my code directory and I dir it in the build.bat. You can see it there. It's right here. And basically I run that build.bat file, and you can see it prints out the line echo off. So the line that I was trying to use to stop it from putting lines out to the console when it did things is actually it's self-echoing. So the at is basically a thing that says don't echo that line either, because you have to, it hasn't turned off yet, so that's the way that you do it. Yeah, Windows batch files, ladies and gentlemen. They're kind of amazing. And so then the next thing that I need to do is I need to compile this program. And the way you compile programs is you use basically the Microsoft compiler is called CL. And if you type it in, what you'll get, even after you've installed Visual Studio 2013, is you'll get this note here. It's like CL is not recognized as an internal or external command, operable program or batch file. And the reason that you get that is because there's a thing called the path. In fact, if you hit set, you can see it. It's this gigantic thing that's happening here. Yeah, kind of crazy. Basically, there's this thing called the path, and what it is anytime you're in this command line, these are all the actual variables that are set in my command line. There are things called environment variables that control stuff. You don't really need to know any of them, honestly, for what we're doing, but path is somewhat important. What path is this thing that says, here are all the places to search. When I type for a command, look in all these places in order, and the first time you find it, go, right? So what happens is when I type CL, it can't find it because that's not in the path. This happens even after you've installed Visual Studio and you're like, how do I get it to go? Well, it turns out that Visual Studio is kind of a little janky, and we're going to work around this a little later on, but at first I don't want to quite work around it yet. I just want to show you how to do the basic maneuver. And what you have to do is you have to go find where Visual Studio actually is, okay? So basically, I don't know if you've ever seen this guy. It's called VCVars32. Anyone who knows what I'm talking about, or I think it's VCVars all actually might be it. Basically what we're doing is we're going to look for a particular program that we need, that Visual Studio installs, that will set up our command line for us to do the compiles from the command line. So where that is you have to first find Visual Studio itself, right? So we're going to type C:, to go over to the C: drive, okay? We're going to cd to what's called the program files directory. And this is a trick, but we're going to go over to the program files directory, which is where you would think it is, and we're going to take a directory, okay? And here you can see Microsoft Visual Studio 12, which is the thing we installed. Now, Microsoft likes to do this sort of stuff. They like to call their program Microsoft Visual Studio 2013, but then when they list it on the drive, it's Visual Studio 12. So you just get to magically find out and know what version number your thing actually is, as opposed to the like branding thing that marketing decided to name it. And they constantly do this. Like, it's never actually named the same thing as it is when you go to actually look for it. It's maddening. It's Microsoft. What are you going to do? Anyway, if I go into there, there it is. If I go into there, I can do a directory, and I will see what is in here, and I can look, and I can start to get nervous because where is all the stuff? It's not here. I know what should be in here. I'm looking for the compiler. I said there was CLXDC. It's not there. Well, the reason it's not there is basically a historical accident. So what happened long time ago, when Windows was still only running on 32-bit x86 processors, is there was, a split, and there was a sort of a push by Intel to go to something called the Itanium processor, which is going to be a 64-bit processor, going to be their new processor line. And in the meanwhile, AMD stayed with x86, and because they didn't have a license for Itanium or any of that stuff, and they started developing their own 64-bit version of x86, which of course is the CPU that is in all of these machines. Well, the Itanium project that Intel had championed did not pan out at all. I mean, it exists, and it's something that you could run, but nobody wanted to go to a completely new architecture and switch to this whole new thing, so that didn't work out. What ended up happening is AMD's 64-bit architecture, which was just x86, that was upgraded to basically handle 64-bit, and that still could run x86 code just fine. That's the thing that won. And when everything in the PC world went from 32-bit to 64-bit, and you had things like Windows 7 64-bit edition and those sorts of things, when you install those, right, those are things that are using the 64-bit capabilities of the CPU. And we'll talk a little bit more about what the difference is between 32 and 64-bit CPUs and stuff like that later on the stream when it becomes more relevant. But basically what happened at that time was Microsoft decided, probably for reasons of trying to make legacy stuff work, and maybe just because they weren't, thinking super hard that day, they decided to make two program files directories. So there's program files, and there's program files parentheses x86. And basically, programs that are compiled to run under the 32-bit version of Windows go into the x86 one, and things that are designed to run on the 64-bit one go into the main program files one. And Visual Studio still hasn't been updated to run on 64-bit computers. Now, it's been, I don't even know how many years since we've all been running, I mean, developers especially been running 64-bit things, but like they couldn't figure it out. They're like, that's not where they're at. So heaven knows why that's going on, but that's the case. So what you actually have to do is go to Program Files x86, and in there, you will see the same directory again, Microsoft Visual Studio 12 or whatever it is there. Yeah, there we go. And in there, now we can actually find the thing that we needed. So when we hit dir inside the Visual Studio 12 directory, you will see all of this stuff. The only one you care about is VC. That stands for Visual C. And we are using C, so that is what we want. We can go in there, and when we do a dir, we will see vcvarsall.bat. And vcvarsall.bat is the thing we actually need to run. So you'll notice CL still doesn't work. vcvarsall.bat If you run that, it'll configure all the stuff, the path, everything. You run CL, and now it works. But there is a catch, ladies and gentlemen. VCVarsAll only compiles for running a particular version of the compiler, either the 64-bit one or the 32-bit one. So if we want to run the 64-bit one, we actually have to call VCVars x64, because you can notice when I ran it, there's an x86 there at the end. So that's the 32-bit compiler, which is fine. I think you can compile 32-bit. You may not be able to. I don't even know. I haven't tried to compile 32-bit code with a 64-bit compiler. I don't know. We're going to start off compiling 64-bit code because that is the most prevalent PC CPU kind, most prevalent PC CPU operating system out there, and it's a more powerful chip type because it has more instructions that we may want to play with later. So we are going to go ahead and run that. And if you put the x64 after it, then when you run CL, you can see that now you get the compiler for x64. Everything's the same except for that little guy right there. Okay? So what you have to remember, and I know it's a little annoying, is you have to remember to run this when you start up your stuff, right? But we can do a little bit better. If we want to, we can do a little better anyway. What I like to do, because I showed you that subs trick before, right? What I like to do is I like to go into the startup folder. See the startup folder up here? If I right-click on, well, actually, I guess you wouldn't have one yet. So I'm going to right-click on startup and hit open. That basically brings up a folder that will execute anything that you put in it when the machine starts up. So what I like to do is I like to drop a startup.bat in there as well. And I just edit it with Notepad. I'm not fancy. I don't even bother opening Emacs or anything. But I like putting a file in there called startup.bat, and I put in the subs line. And so while you're in there, you might as well go ahead and run VCVarsAll right from there, right? Now there's a catch, of course, because there's always a catch. The catch is that if you're in a batch file and you want to call another batch file, in order to be compatible with the most number of command line settings that people might use, you have to use the command call. Do not ask me why. I really do not know. I think it's some historical reason about they had to set some state in order for the other one to come back to here after you finished it and blah, blah, blah. But assuming that you want this to actually dispatch to the other batch file and then actually come back and execute any more lines you might put in the startup. If you didn't put any more lines here, you'd be fine. You'd just go execute that and that'd be it. But assuming you actually want it to do this and come back, you could put that in there. Now, the only thing I'm not sure about, because I don't always do it this way, is whether that's sticky for the whole system. I don't know if it is. It might not be. And so the other thing that you can do, I'm just showing that as one option. You can try that. I'm not going to spend time trying it necessarily on the stream. The other thing that you can do, and this is also pretty cool, since this definitely does work at startup all the time. The subs always works, so I always put that in there. The other thing you can do, and the way that I'm going to do it, because, you know, I don't have a because. I'm not even going to say because I don't have one. And, you know, don't make up a because if you don't have one. This is just the way I do it. So maybe that means it doesn't work in there. I don't know. It just is the way I've always done it, so I'm going to do it. So in here, I've got my Handmade. I've got my MISC directory where I put stuff that, you know, you don't have to use. You can use it if you want to. I'm going to go ahead and I'm going to create a batch file in here, and I'm just going to call that shell.bat, right? I'm going to call that shell.bat, and I'm going to edit it. And in there, I'm going to put the actual thing that I'm going to call, right? And so that way, anything that I want to happen, any sort of configuration for the shell when I start it up that I want to have happen, I can have happen in there, if that makes sense, right? And there's some things that we might want to do. Actually, I can show you some other tricks that are pretty cool that we might want to do in there. For example, we could also make the path point to something in our directory. So if we want to put like little tools that we have or things like that in there, we can actually make it so that that happens as well. So for example, if I wanted to, let's say, so let's say I want to make the path point to something in our guy. So I can do set path equals %path, which just means insert the old path in here, right? I can do that. Set the path equal to the old path. Oh, well, you know what? Let's put ourselves first. Why not? I'm going to make it so that it looks in our Handmade directory and underneath MISC, right? So anything in the Handmade MISC, and you know what? Let's go even further than that. Let's make it, should we make it bin? Nah, why complicate things? So I'm going to make it look in the Handmade MISC directory. And so that way, anytime we run something with the command line, it can look in there, and it can actually just run it if there's something in there, right? And so that'll be pretty cool. So now what happens if we actually go in here, if we actually run this guy, right? Let's see what happens when we do CL. Yeah, CL is not recognized an internal or external command. So I was right to suspect that we probably can't put it in the startup. Because if we put it in the startup, it's only going to be scoped to that little startup shell. Like if you notice, right, basically what happens is I go in here to startup, I run this thing, it kind of flashes, it does the command, it goes. Subst is sticky. It works for the whole machine. You can see even Explorer gets that W drive that I decided to make. But VCVars all just sets local environment variables to the shell. And so it has to be local to that shell. So basically what we want to do is at shell startup, when we actually start the shell, we want to do those changes, right? So we want to make sure that we can basically go in here, right, run our shell.bat. Oh, that's good. Already got a typo. We haven't even started programming yet. Anything that's got spaces in it, since spaces are considered delimiting, you got to enclose them in double quotes. I forget that all the time, and I suspect you will too. Anyway, I run that, and that'll run our VCVars. And now we'll get our CL back, and we're good to go. We can go one step further, and, well, you know what? I may even remember this command line switch. I'm not going to promise it to you. But I think I may actually remember the command line switch for telling the shell to actually execute something on startup on its own. So we don't even have to go in there and run that. Is it /k? Do we think it's /k? Does anyone want to place bets? I think the stream should place bets. Some people in the stream know. We're going to look it up in a second, but we're just going to type /k for now. We're going to type /k, and then we're going to tell it to go ahead and run handmade misc shell.bat, like that. And we're going to see what happens. Bam! Did you see that? Did you see that? That is a useless set of neurons right there, ladies and gentlemen. Remembering stuff like that. That's what happens when you get to be 38 years old now and have dealt with this stuff for far too long. Okay, so now we are at a position where we can double click on that icon and we can actually run a compiler. Congratulations. That is some big, big news right there. Surely it's not very far to a complete game from there, right? Surely. Okay. So anyway, if we can do a CL, then we can basically build an executable. That is mostly all we need. So if we go in here, and I guess I did that setting that path to Handmade. I didn't actually show anything that we could do in there. I set the path to there. So basically, obviously, we could run shell again, and that would work because it found it in the path. Now remember, shell wasn't there, but it went and looked in that path that we set. If I click set again, you can see that I've got right here, it now inserted me into that path. So it's looking through each of these, right? And it's going to find the stuff that I put there. So now that I've got that set, I can put something else in there. So why don't I, instead of running Emacs from an icon, let's stop doing that. There's no need for that. What we can actually do instead is we can run Emacs directly from our shell. So basically, the only thing we'll start up is this. Okay. So, and you know what? I'm going to close this as well. So we're gonna have a little party here. Okay. So if I want to, I can basically make another batch file. So inside handmade misc, I will make notepad, and I will go ahead and say that this is going to be my Emacs launcher. Save. Oh, you know what? I should give it a name so that I don't have to actually enter it. Notepad emacs.bat, and I do want to create a new file. I'm going to echo off, and I'm going to go over here to the GNU Emacs icon that I had, and I'm going to copy in what was in there. Okay. So what's interesting about this, and I'll show you this part as well, because I'd customized this icon, and it's good for you to know if you do want to follow at home with Emacs. When you do this run Emacs command to run Emacs, and this has to be wherever you install it. It comes in like a zip file, so wherever you unzip it, you're going to have to find the run Emacs command, and you're going to have to call that. I unzipped it just into program files x86, where everything else that's x86 goes. Why not? But you could put it in something more sanely named if you wish. -q -l w handmade misc.emacs is just a way of saying load this as the config file. I think wq might be quiet. I don't even know what wq is. -l loads this file right here, I believe, which is the one that I created my custom Emacs file. And so that way it will come up with my settings. So I'm going to go ahead and save that. and close it. And now, no matter where we are, in theory, if we wish to summon our editor, we can type Emacs, and boom, there it is. Close it, comes back, everyone is happy. And we're starting to get a little closer to a machine I can actually use to develop code. The other thing that is good to know is devenv. Devenv is the name of the actual Visual Studio IDE. And if I type that in and hit return, it will load it just like I clicked on the icon. And now we are at the point where all we need, bloop, bloop, is just our command prompt, ladies and gentlemen. So get rid of those icons, they are gone. So that is the drudge work of setting up a machine to actually develop on. If you want to have some of the same stuff that I have, obviously, you can go grab GNU Emacs yourself. You can search for it here. You can go to GNU Emacs and it will come up. You can click through to the various fun locations. I think there's an obtaining. You click on obtaining. You click on nearby GNU mirror. And after clicking on that, there is a Windows directory that you can click on to go in and get the correct one. I am using, because a lot of stuff has broken in recent Emacs, I am using version 23.4.1. And so you can go in and you can download 23.4, which is this bin, 23.4 bin i386.zip. That's what I'm using. Okay, so we have about 20 minutes left to go, which is plenty of time to get our code working. Drudge work done. Here we go. So I'm going to actually go in here to Handmade code. I'm going to hit Emacs, and I'm going to open up my build.bat. I can now take this Win32 Handmade thing that I made here, and I'm going to say I want to build this code, but I don't want to build it where it actually is right now. I don't want to build it right in its current location. And the reason that I don't want to do that is, well, you know what? Why tell you when I could show you? So CL is the compiler. If I want to compile something, I can actually just type CL Win32 Handmade.cpp, hit return. It will then do the compilation, and you can see that it spit it out. Here is the Win32 Handmade.exe. Here is the Win32 Handmade.obj. Now, I will be getting a little bit ahead of things here, so you don't have to worry about this too much, because we'll talk about compiler switches in a separate episode later on down the road where we talk about optimizations and stuff like this. But when you do CL, if I put /zi, that will actually cause it to generate what's called debug info, which allows us to debug the program more effectively. When I do that, you will notice that we start getting a lot of crap in here. There is just a lot of crap in here. There is this PDB file, which is debug info that's spit out. There's another PDB file, which is a separate thing that it uses. These are both part of the debug info, I believe. Don't quote me on that. They change it every version. I don't know if you can maybe get rid of this one. I don't think you can. I think you need both. The OBJ file is the intermediate file that it used when it first compiled this. This was the thing that it linked with. I think this is some kind of incremental linker data. So it's going to start spewing stuff into our directory. And I don't want my directory to look like that. That is not okay. That is not okay. I'm getting rid of those PDBs. You'll notice I did del star.pdb, which basically says delete everything that's got a .pdb at the end of it. I'm going to delete star.ilk. I'm going to delete star.obj, and I am back to what I actually wanted, which is just the exe. So I'm even going to delete that because we're going to try and make that a different way. So what I want to do is I want to basically force all this stuff to go somewhere else to keep my source directory clean. So what I'm going to do is I'm going to use a thing called pushd popd. Pushd and popd means push directory, pop directory. So I'm going to build this back a few in build, I think. I'm going to go back to, this is the syntax for back a directory. So I'm going to go back 2 directories from where we are. So out of code, out of Handmade. And I am going to go into a build directory. Now, of course, that may not exist, so I'm going to double check that it's made first. Then I am going to CL this file. I'm going to CL handmade code win32_handmade.cpp, like that. And then I'm going to pop d back out, so that will bring me back to where I originally was before I ran this build.bat. Now, that's not strictly necessary, but basically pushd and popd are sort of like enclosing something you do in a block so that when you're done with it, you return to the directory you started from so you don't have to remember it, right? If I was to just use a cd here, it would change the directory permanently, and that's not going to be very useful. So here is my build.bat. I build it, and oh, not off to a good start. It cannot find my, oh, how about that? I'm using the wrong, you can tell, can you tell I use Linux most of the day? Linux, of course, uses slashes for directories that go forward, and Windows uses backwards, and you can't, you can't mix and match the two. Although you should have been able to do that. You know what I think? You should have been able to do that, shouldn't you have? Oh, you can do it in the CL, I bet. Let's take a look. No, maybe not. All right, what's going on here? Let's take a look. Handmade, code, Win32, dude. Win32_handmade.cpp. What is the complaint? Syntax of the command is incorrect. Oh, wow. Well, I'm very glad I decided to show you that, because I believe that means that we did not actually enable something that we needed to enable. Windows, ladies and gentlemen, it is always fun. So I believe this may actually be, let's see, push D. Let's see, push D. You're going to have to get used to this, by the way, because this sort of thing is going to happen a lot, especially in things that haven't done for a long time. So that actually works just fine. The push D works fine the way that it appears to be here. The make dir works just fine. So what is it actually complaining about? I don't actually know. Is this just because we don't have command extensions enabled? That would be strange. At least I feel like that would be strange. But it could actually be true. I always use them. I always have them enabled on my machine. No, it worked fine. So there you go. It always works. Cannot open source file handmade code win32handmade.cpp. No such file or directory. So I'm going to actually just go ahead and see. Can we do that here? So that I can see what actual directory it ends up in when it tries to do the build. So it ends up in wbuild. Oh, duh. Okay, everything's fine. I'm just not thinking straight tonight. That's totally fine. So what I did is I told it to go into the build directory, and then I told it that this was the path to the thing, but it's not the path to the thing. Because, of course, these paths are all relative. I'm using relative paths instead of absolute paths so that you can build it on your machine wherever you happen to put it. So instead of typing w:handmade, right, if I type that, it probably would work just fine, and you can see that it does. But since I tried to use a relative path, I forgot I'm inside the build directory. So I have to go back out one to get it. Yeah, fantastic. This is the kind of stuff that you love to do when setting up a machine. So that actually builds, as you can see. It did the build. It didn't dump anything in our directory. And so now if I dir that build directory, you can see our Win32 handmade executable. There it is, right? It's just sitting there. It's ready to go. All's well and good. Now you may ask, where does all the complicated build stuff come in? Well, the answer is there isn't going to be any complicated build stuff. That is what you see right here going to be the way we build this project right up till the day we ship it. And I'm not kidding. If you think I'm kidding, I'm not kidding. We are going to be totally fine. You'll just have to trust me on that one. So that is really all you need to build a project. Now what's going to happen here, and this will change a little, is we are going to start putting things on this line that are options to the compiler, though, because the compiler has a lot of options, and we are going to do stuff that tells the compiler that we want it to produce certain types of executables and these sorts of things. We're going to control a bunch of stuff about it, and so saying it's exactly this isn't quite true. But this is the entirety of the code that will be happening. Basically, we'll just be adding things to this line. We'll probably set some variables up here equal to like a set of debug flags and a set of release flags, and then we'll pick which one we're trying to use at any time. So the only thing I'm going to do is, again, I'm going to jump ahead a little bit here, and I'm going to add some compiler files. I'm just going to tell it to generate debug info, that debug info that we talked about before. I'm going to build that, and then back in that build directory, we should be fine. There it is. So what we can do now is we can actually go and step into our code. We actually have a working Win32 program now, built by the command line using our own batch file, which is all good, all good. If I now want to actually go and step into that and look at it in the debugger, that devm thing that brings up Visual Studio, we just have to call that with the actual path to the executable that we are going to run. So there we go. Up comes our project. Now, if you click in Solution Explorer, you will see that what happens, you know, we never created a project right in here, so what happened? Well, basically, if you tell devm to just load an executable from the command line like this, it will just make a dummy solution for it with that executable, and you can go in and set the debug properties on it just the same, just as if it was some project that you had created in here, right? So what I do want to do is I do want to say where we're going to run from, because one of the things that's true in any low-level piece of code is that you basically have a directory that the program was launched in, and it's called the current working directory. And basically everything that you do when you reference things in your code, when you try to load files, if you use a relative path, like the kinds I was using here, and just to be clear about what a relative path is, again, it's something you should probably look up on your own. It's very straightforward. But a relative path is basically saying, I'm at some place, and you can see the current working directory for my shell right here, w handmade code, right? But if I want to reference something, I can use an absolute path by saying the whole path. Like dir w:build says dir that directory that from, tells me exactly where it is, and it does it. But I can also use a relative path, which is go back 1, go back 2, then go into build. That's relative. But the question is relative to what? And so basically, just like the shell has a current working directory, we have a current working directory. And that current working directory is important because if we want our game to run without any external knowledge of where it is, we kind of want it to load things out of wherever it happens to be and wherever the user happens to run it. So to set ourselves up for success, I am basically going to say, well, let's make a directory under Handmade, right? Called, I usually call it data, to be honest with you. I know it's not a great name. I'm open to other suggestions. So I'm going to make a directory called data, and I'm going to say that we're going to put basically what we will be shipping with the game. So the packaged art, assets, or anything else like that, I'm going to put those underneath the data directory. So in order to tell this that when we debug the program, we want you to run it in that directory. I'm going to put that, into the home directory so that it knows the working directory, so that it knows that that's where I want it. So I'm going to go in here. Well, I'm just going to type it in. The browser. See working directory. I'm going to type into working directory. I'm sorry that's tiny. Hopefully we will almost never be editing these project settings, so hopefully you don't even really have to read this. There's a thing called working directory. We're just going to put in that handmade data, and we're going to hit return there, right? So now when we run our code, it will run it as if it was running out of this directory, so we can kind of always be running sort of in a closer configuration to what we will actually ship to end users who buy the game and want to play it, so that we won't have surprises down the road. Okay. Furthermore, this arguments field here is where we'll put things that we pass to the game for parameters and stuff, debug parameters that we want. All right. So once we've set that, we can hit F11. And F11 will, oops, I gotta close this properties window. Oh, no, it closed it for me. Why, thank you. We're gonna hit F11, which means start our application and stop on the first line of main, which is exactly what it did. And you can see the little thing highlighted here where it stopped. This is actually our code. This is the thing that we built. It's exactly what we hoped for. So we can go like this. It ends. Our first Windows program, ladies and gentlemen. But you may ask, what is all this stuff here? That's a very good question. We covered it in the intro stream, but I'm going to mention it a little bit in this stream as well, because it's kind of important. So now that we have a build going, we can start to look at actual Win32 code. When I said this was the entry point for Windows, what does that mean? What is an entry point? For those of you who are well familiar with programming or who took the intro, who watched the intro stream, you know that this is a function. It's something that gets called, it executes the code inside of it, and it returns to whoever who called it. And that is what it does. But the question is, who called us and how did they do it? Well, the answer is that in this particular way of compiling, which we're doing right now, it's not actually Windows, the operating system, that calls into us. The person who actually calls into us is the C runtime library. Now, the C runtime library is something that ships with all C compilers as mandated by the C specification. And if you go online, in fact, you can look for C runtime library, you will find probably some documentation somewhere that talks about what is in it. So let's see if I can get something, for example, here. Yes, here we go. CRT, C runtime library features. If I go into something like files and streams, and open that up, you can see that it's basically got a bunch of documentation that tells me about the sorts of things that this thing can do, right? It's like some, here we go, here's some functions that are in that C runtime library, set locale, wset locale, who knows, we don't really care about these. But point being, this is stuff that is not part of Windows. It is not in the operating system. It's just part of the standard library that everyone has to support when they ship a C compiler, because code will be written to expect it to be there. That's all well and good. We won't really be calling any of that, but the truth of the matter is it's actually very, very difficult nowadays to build an application without the compiler essentially sticking the C runtime library in there. So I'm not really going to call hardly anything from the C runtime library because I want to show you how to make basically everything from scratch yourself, but we will still have to link with the C runtime library, because if we don't link with the C runtime library, the compiler is going to be very unhappy. It counts on the C runtime library for a number of things, like stack probes, like C++ initializer lists that happen at startup time. All sorts of things are actually hard-coded into the compiler to call into that C runtime library, so that if it's not there, you have to implement all that code yourself to compensate for the fact that the compiler was basically doing a lousy job. I don't think that's particularly useful, and nobody I know actually ships without linking to the C runtime library, so we are not actually going to address that here. But what that does mean is you should be aware when you get called, it's not Windows who is calling you. If I hit F11 here, I can bring up something called the call stack, right? And what the call stack is, oh, awesome. Is this not set? There we go. Okay. So basically, you can see it came up in I guess, what you might want to call training wheels mode. The call stack is a thing that shows you where you are in your program, basically by showing all of the functions that have been called, that called each other, that called each other to call to you, right? It's the entire stack of functions up to the point where you are. So it decided to only show me my actual function, right? It didn't show me any functions that were outside of us in the C runtime library. But it looks like there's a button here called Show External Code. You can see it right here. There's a checkbox. If you hit Show External Code, all of a sudden you can see there's this other stuff that happens. ntdll.dll and kernel32.dll are the actual operating system. We're going to talk more about what DLLs are and that sort of stuff much later, so don't get too hung up on what those are. But point being, that's code that's actually in the operating system. If we jump out there, we're just going to see assembly language code. That's basically stuff that's in the operating system that we don't have source code to, because Microsoft does not release the source code to Windows. But after Windows calls in to our executable, you'll notice the first thing that's called is not us at all. It is actually some code we didn't write. It is crt0.c. And you can see that if you hover over it, you'll actually get a tooltip that shows you where it is, and it's actually out in the Visual Studio directory. So this is the code that they shipped with the C runtime library. And they ship the source code to the C runtime library, so even though it's compiled code that we're in right now, we can actually view the source, which is kind of nice of them to provide that so we can see what's going on. So as you can see, there's a whole host of things that happens. And this is actually the place where things start up in Windows, right? So if we really, really, truly want to see where the code starts when Windows calls us, when Windows loads our executables, does its patching, and gets us ready to go, this is actually where the code starts. These things all happen first. They're in code we did not write, and they are doing a bunch of things to set up the C runtime library, which unfortunately we're not even going to use. But it's good to know that it's there, just so you don't get confused. It then will actually dispatch to us. And so you can see, if I step into there, that's where we go, right? So it's all good. That is what is actually happening. All right, so one more thing I want to do, just to get things to a place where we have done all of the judge work, so that we can actually do something interesting on tomorrow's stream. If I hit, let's see, I want to be able to basically make it so that I can compile my code from inside Emacs, but I don't have it set up to do that yet. What I want to do is I want to make it so that I can hit Alt-M basically, and I can basically, oh, you know what? I think I can actually just do it right here. Does that actually work? No, I guess it doesn't. You know what? Maybe I'll save that to next time, because I don't actually want to kind of complicate things for that amount. We probably have maybe 5 minutes left on the stream. I will show you how to get that stuff working in the next one, But for right now, I guess, what we could do is we could at least just have our Windows program do something so that we know that it's actually running and doing something amusing. So what I'm going to do is I'm going to call a function called messagebox.ex. Why not? Actually, I guess I could just call messagebox, but I think I want to call messagebox.ex because it's a little more fun. Messagebox.ex is just something that pops up in MessageBox. It's the easiest thing for us to call that we can quickly see that our code is actually working. So if we look at it here, we can see what it actually calls. We can look at MessageBox and see if it's a little simpler because they both do exactly the same thing. Yeah, that's even simpler. So we'll just call MessageBox. It's even simpler. MessageBox basically takes a bunch of things that we'll be covering more in detail what they actually are. But the hwind is basically a handle to a window. And we haven't opened a window yet, so we're just going to pass 0 there. It then takes a string, just a regular old string, ANSI string, that's basically what you want to, excuse me, what you want to display in the message box. This is Handmade Hero. And it has a caption, which is the thing that appears sort of as the title, I believe, of it. So we'll just make that Handmade Hero, right? And then it has like a little sort of I want to say a predefined value here that basically says what kind of like icon it is and what you want it to be. Well, we don't really have anything to ask the user, so we're going to pass MBOK. And we don't really have, I guess, anything in particular we want to warn them about or anything, so we are going to pass icon information. So for those of you who were with me in the intro stream, this is a bitwise operator. It ORs things together. If you are uncomfortable with that, I highly recommend watching the intro stream because it will tell you about that operator and how it works. But in that stream, people were asking, do you do much bitwise manipulation in real coding? And I said something like, I bet we'll do some in the first stream. You do it all the time. And ladies and gentlemen, even though I was not planning that, you can see right here that it actually happens. And the reason that it happens is because the way that people often like to do flags, like when you just want to set some flags, like, okay, I'm calling this function and I want to set some things like do this, do that, don't do this, don't do that, just some little booleans like toggles. A lot of times what they'll do is they'll use a bit field, which is basically saying that each bit in a particular size thing, like in a 32-bit value, each bit means a specific thing. And what you'll do is you'll OR the bits together to set the things that you want set. So in this case, we want MBOK to say that it's a dialog box that has an OK button. And in this case, we want icon information to say we want to have a little information symbol next to it. And we're going to OR those two together to basically say that that is what our dialog box is going to do. Now, if I go ahead and do our build, oops, if I actually go to the right directory and do our build, it will rebuild our thing. Oh, and we get to the other part of our build. So when we actually call something, and this is a little bit confusing. This is one of those things that you wish the compiler didn't do for you, but it does do for you, and so it's kind of a little confusing. But when you compile a program, as we did here, and you can see our command to compile our program did not actually include anything other than our code, right? It's handmade.cpp. And when I built it, you saw me run it and everything worked properly, so you're like, oh, okay, that makes sense. I build this CPP file, right? It compiles the code, it links it together, it builds that executable, all the stuff we covered in the intro stream. If you're unfamiliar with it, you can take a look at that again for more detail. It builds our executable and then we run it and it's all good, right? That's all that had to happen, but that's not actually entirely true. What actually happens is Windows needs to basically bind to us. And we did talk about this in the stream a little bit too, but Windows basically needs to find the places in our executable where we tried to call it. And it needs to be able to go in there, reach in there, and patch those locations to point to its own code that's running at that time in memory, right? And in order to do that, it uses what's called an import library. What happens is when you actually build your program in here, and it links together the OBJ files and makes an executable, what it has to do is it has to have a library that says, here are the functions that Windows actually is going to call. Here are the functions you're going to call that are in Windows. And I'm going to put little markers in. This library tells me how to put the little markers in and where they should go so that they can actually be found by Windows when it loads it. And off you go. And in the intro stream, I drew a little diagram that shows like how that works, where Windows loads it, it looks at the table of fix-ups, it goes to it patches your executable, and that sort of stuff. So if you're interested about that, I highly recommend watching the episode of the intro stream that talks about that. Anyway, the problem is we didn't specify any import library. So technically, we should not actually have been able to call anything in Windows at all. And I don't actually know if it's true because I think they may sneak kernel 32 in there. I'm not actually sure if they do. You know what? I'm just going to go ahead and test it since I know how to test it. Let's actually just call, well, you know what? I'll call get module handle. Let's see. Yeah, so they do. They actually do sneak it in there. So basically what happens is they sneak in one import library, or at least one import library. The import library that they sneak in is the import library for the kernel. So basically you're allowed to call things that happen to call into the kernel. You can call those. We'll see a bunch of them when we actually start programming Windows for real tomorrow. You'll see a bunch of calls. But when you call into the kernel, you're actually fine because they snuck it in there for you. If you call into something else, for example, the UI system, which exists in something called user32.dll, it doesn't include it. So basically what I have to do is I have to go in here and I have to specify, and I'm totally doing this by memory, I'm assuming this is correct. Is it linker or linker? I don't even remember what it is. What is the option for the linker? In fact, do I even need to specify the option for the linker? No, I don't. Never mind. So anyway, if I go in there and give it the import library that I actually need to call the function, where that function is actually mentioned so that Windows knows where it is, then all of a sudden my code compiles, right? If I don't do that, if I don't specify the import libraries that I need, right, and I compile it, then I'll get what's called an unresolved external symbol, again covered in the stream. If you don't know what that is, they happen in other languages as well, so hopefully people are familiar with them. But basically what it says is, I can't find the actual call that I need to make. That you're saying that Windows.h defined, I can't actually find where that function actually is. And it makes sense that it can't find it because we didn't define it and neither did Windows.h. All it did was say that there was one. So what the library does is it actually gives it the information it needs to actually sort of insert the placeholder that says when Windows loads this, patch this up to call into Windows code, because this doesn't exist in our executable, it exists in Windows. Now, the question is, how did I know that it was user32? I mean, I knew because it was memory, but what would you do if you didn't know that? Well, the answer is, I said, you got to get used to using MSDN, and I meant it. What you want to do is you want to scroll down to the bottom of MSDN's documentation on the function you're trying to call. And down there you will find explanations of that particular function. Now you will see what the minimum client is that you can call it. And if you care about server, then you actually can find that as well, but we don't. We only ship to basically client OSs. We're not going to ship to people running servers, certainly. The minimum supported client, so you can find out if that function is callable by you on your target platform. So if I'm targeting Windows 95, let's say, I can't call this function. I have to call some other function, let's say. Now, I actually think this function was in Windows 95, so I think this might be a little aggressive when it says Windows 2000 Professional. But point being, certainly anything after that's fine. Windows XP, and which is Windows XP would probably be our minimum platform, right? So we're scot-free. It tells you what header it's in. Basically, it says, well, it's in WinUser, but include Windows.h, which includes WinUser. It tells you what DLL it's in, so that's actually what will get loaded at runtime to actually support you. And we'll talk about what DLLs are later because we'll be manually loading them for things like the gamepad support. And it tells you what library you will need to link with. So all I did, right, essentially was I short-circuited this process because I knew, but all you actually have to do when you call something is go find the documentation for the function, go down to the bottom, and right there it will tell you what the lib is that you need. Now there's one other thing. We covered this in the other stream, but I'm going to mention it again. A lot of functions, if they take strings, in Windows they have an ANSI and a wide character version. The wide character version is if you have UTF-16 encoded stuff, and the ANSI version is if you have just regular old ASCII that you're going to try and pass it. Now you may wonder why it has these two, and I called this message box function, like what's going on there? Like that doesn't make any sense, right? Well, the answer is because in all of Windows, everything that takes a string is actually not the function that you actually call. You actually call a macro. So inside Windows.h, there's actually a pound define, which is how you do macros in C, how you replace text in C. There's actually a pound define that pound defines message box to message box A or message box W, depending on whether or not you're compiling in UTF-8 mode or ANSI mode. By default, if you just call CL, the compiler is set to compile without being in Unicode mode. So it's going to compile in ANSI mode, which means that we're going to call message box A, which is what we wanted because this is an ANSI string. But if we were trying to pass UTF-16 to it, we wouldn't have to switch the compiler to compiling in Unicode mode, which is basically putting in a pound define or anything like that to switch it, or we didn't have to do anything like that. We could just go ahead and stop using the macro. The macro is just something Windows did for backwards compatibility a long time ago. So we can actually just short circuit that process entirely and call the actual function that we actually wanted, and that'll work just fine, as you can see. Again, we need that user32.lib to make sure that it can find it, but other than that, we're good to go. So now, if we go to our program and we run it, take out the breakpoint that I set there, you can see that our app now actually prints something on the screen. This is Handmade Hero, Handmade Hero. Now that is completely uninteresting to me. I would much rather see some sprites flying around the screen. But like I said, there is a lot of drudge work in getting a project up and running, and we had to do that all tonight. So in order to keep this stream to only an hour, I will, even though I would love to go spend the next hour so we can actually put some graphics on the screen, I am not going to do that. I'm going to stop. We will do that tomorrow. And honestly, I guess I would say that went pretty well because we got everything out of the way that we need to get out of the way to build, run, and have fun on Windows. So from here, tomorrow at 8 p.m. Pacific time, again, we will probably be able to, I think, open a window and draw some stuff to it. We may not get to user input yet, but I think we'll be able to open a window and draw stuff to it. And the day after that, we'll get user input for sure. Basic user input, but user input nonetheless. So with that, I'd like to thank everyone for joining us for the first edition, the very first episode of Handmade Hero. It has been delightful, even though it was drudge work today, which is what happens at the beginning of every project, I'm afraid. Even though it was drudge work today, I still enjoyed going through it with you, and I hope that you will come back tomorrow when we will do something, frankly, a lot more exciting. But we will still be dealing with Windows a little bit, so we're still not quite out of the drudge work. It'll be more exciting because we'll be able to actually see things happening, but the real excitement will probably pick up in a week or so when we're off of Windows and actually just dealing with all fun game code and rendering code, which is just so much more exciting. That's why I like to do it instead of sitting around programming Windows all day. If you would like to be on the source tree, or if you already are on the source tree, you can pre-order the game here and you will get it. It will give you an email. So for those of you who got that email, there's a link in there. And what I will do is tonight I will upload this code, this setup that we made. I will upload that, and so you can go back to that email that you got that with that link in it, which you should bookmark because you can go back to it all the time and download the code. You can go there, you can download that code, and you can be set up just like this so that you can see everything that we did. I know I went fast through everything today, and we're going to be going fast through things. That's just what we're going to have to do to actually get through a meaningful amount of stuff in a reasonable amount of time. But while we're going fast, I think it's easy if you can go back to source code, look through it yourself, think about each individual thing. What did he say about this? Make sure that you're comfortable with it. If you're not comfortable with it, ask questions. Go read that MSDN, get comfortable there, play around with it, call some other stuff, change this message box EX, play with the build, play with the compiler, do all that stuff, because really the way that you're going to learn is not just by watching me. What I do here on the stream is basically showing you sort of the backbone, showing you how to make the game sort of like by example. But what's really going to solidify it for you is you trying it yourself and you doing these things yourself. So you should go back now and try all the things that I just did, all of that stuff. Try it yourself, play around with it yourself, make the mistakes, make the same mistakes that I did, make different mistakes, and really get comfortable with that stuff. And if you do that every day, you just spend an hour or two redoing the stuff that I did and learning about them, that's really going to be what solidifies it for you. Because if you just watch me, I mean, if you're just entertained by watching me code a game, that's great. There's no problem with that. But if you really want to learn how to do this stuff, definitely go through, do it yourself, ask questions, go on the internet, find resources, just do some reading, really soak that stuff in, because that's what's really going to make the difference. When you actually go and do it yourself and sort of struggle through it a little bit and go, oh, what did he do there? Oh, right, he did this. Go back to the video, see what's going on. That process is what's going to really drill it into your brain, and then you're just going to know it, and you're going to have it down cold. So that's really the thing to do, and I encourage everyone to do it. So that's it for this stream. There will now be about 30 minutes of Q&A, and I will stop the recording now so that we can have two separate streams on YouTube, and so people can sort of jump between the Q&A and the regular. So I will see you back here in just a few seconds for the Q&A.